Hey, let's take a look at shapes in the coordinate plane and see if we can find their perimeters, their areas, see what's going on. Well, here's a really crazy shape. Look at that thing. Let's see if we can actually estimate the area of this wild thing. And I want to do it two different ways. First of all, let's estimate it by a composite figure. We can then find the area of each piece. And then even a more wacky way. Well, so if we want to create a composite figure, what can we do? Well, we could look in here and see that there are lots of pieces that sort of fit nicely. Like right here. That's a trapezoid, so that looks good. This is another trapezoid here. That looks good. Actually, there's a big rectangle I could put right in here. Put a really big rectangle in, let's say right here. By the way, there's not like one way of doing this, so you might see different ways of breaking up pieces that you see. Don't worry about it, it's all good. I'm just showing you one way. But there's not like a unique answer, like, oh my goodness, I wouldn't have seen it that way. Yeah, it's okay. See it the way you want. Let's see, and here I can put a trapezoid in like this. Put a little trapezoid in right here. Put a triangle in here. Alright, so look, actually that's pretty good. So I cut up into a lot of pieces, and each piece we can actually find the area fairly easily. I'll do a few of them and then we'll start to speed it up a little bit here. Let's start down here. Here's a little right triangle. Base is 1, the height is 2, 1/2 base times height, 1/2 of 2 times 1, which is just a total of 1. So this area is just 1. This little rectangle right here, it's easy to count. 1, 2, 3, 4, 5. It's a 1 by 5, so it's 5. This rectangle is actually pretty straightforward. Let's see. I've got 1, 2, 3, 4, 5, 6. So I've got 6 times 2, which is 12. And let's see, what about this thing here? Well, this is now a trapezoid, so its one base is 3, one base is 1. We take the average, we get 2. 2 times 3 is 6. The height is 3, so we multiply and we get 6. So the area of that little piece there is 6. Actually, similarly, this is the same exact dimensions, right? I see one base is 1, one base is 3. When I add 3 and 1, I get 4. Take half of it, I get 2. Multiply by 3, I get 6. Okay, it's not so bad. Here I have one base of this trapezoid is 1, one is 2. So when I average, I see 3. 3, take half of that is 3 halves. Then I multiply by the height, which is 2. 3 halves times 2 is 3. So I get a 3 there. How are we doing here? I think I got all these things covered. What about this little piece right here? One base is 3, one base is 1. When you average, you add them up, you get 4. Divide by 2, you get 2. Multiply by the height, which is 2, and you get 4. And then finally, this little sliver of a triangle, it's 1/2 base times height. That's 3 times 1, which is 3, divided by 2 is 1/2, so it's 1.5. Okay, and I think I've actually done it. So now, all we have to do is add up all those pieces, and that will give us an estimate to the area. So let's see if we can do that, hopefully correctly, but probably not. Let's see. So I had 6 and 3 is 9, plus 12 is 21, plus 5 is 26, plus 6 is 32, and 1 is 33, and 4 is 37, and 1/2 is 38.5. So the area is approximately that, and the units here are, were we ever told, by the way? Let's say units squared. Great. So that's one way. Now let me show you the other way, which is a lot faster. Instead of cutting things up into shapes, let's just count which squares are completely or nearly completely inside the thing, and then we'll count the ones that are sort of half in, half out. So let's count the inside ones. So completely inside. That square is completely inside, so that's area 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's half. That's half. 10, 11, 12, 13, 14, half. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So I'm going to say there are about 31 full squares in there. Now, how many half squares are there? Let's count the half squares. So I'll count this as 1/2. So I'll say this is half, half, so it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and this one here we missed, 14. So we'll say there's 14 halves. Well, 14 halves means that if I take half of the 14 halves, I'll get the total number of fulls, which equals 7. So I see 31 plus 7, which equals 38 units squared. So you can see just by sort of counting the squares, we got a pretty good estimation to the area that we already estimated to be 38.5. So not bad, not bad. Exotic shaped things in the coordinate plane, no worries. Just count little squares and see what you get, or try to approximate by composite figures.